Okay, before we start prototyping our mechanism, we're going to get our servo set up here. It's important before you start prototyping to get your horn attached and make sure you test your servo. These are pretty inexpensive, and occasionally they send one that doesn't quite work right. So I'm going to dump out all the contents of our bag here. So they give us a variety. I usually put this one on here because it gives me the most flexibility. Some of the nicer servos, you might get a disc as well. So we have our servo tester here. We have our battery pack. And on our tester, we have 3 pins on one side, and that's where the power goes. And there's 9 pins on this other side here, and that's where the servos go. So you can add up to 3 servos there. It also says power in and out over here, but those are such tiny letters, sometimes it's easy to mess up. And you can accidentally plug this in on this side, and the lights will light up, but it will be confusing and it won't work. So, okay, that doesn't work. Flip it over. Now we got lights. I'm going to go ahead and plug in my servo before attaching the horn. Okay, you can hear it's going there. Probably can't see. You can hear it moving, but you can't see it because we don't have a horn on there. And that's why these are handy, because we can push this button here, and this should be right on a standard servo like this. Should be like right at 90 degrees. So it's in the middle of its rotation right now. So now I'll go ahead and press my horn on there without putting the screw in, and go to the next mode. Okay, that looks pretty good. Now I'll go to all the way over there, all the way over there. Has a little bit more travel on one side than the other, but I think for what we're doing, that's going to be just fine. Now I'll just drop one of these screws in here to secure our horn. Okay, great, that's done. For those of you who are observant, you might notice that we're running 4 AA batteries here into a controller and a servo, which is probably rated for 5 volts. This is about 6 volts of power, and the batteries are fresh. And you may encounter in your reading about servos that you should never run more than maybe 5 volts or 4.5 volts into a servo. And these materials are so cheap, I've never had a problem. But if I did break one from running too much voltage through it, that wouldn't be a big deal, and then I would know something about what the material is capable of. So whenever you're prototyping anything, I recommend not worrying too much about the rules, especially if your materials are inexpensive, and seeing what you can break, because you learn much more from breaking something than being afraid of breaking something. Whenever I start prototyping something like this, I'm going to have a lot of different materials laying around ready to go. I'm going to have a selection of just small pieces of cardboard, so that every time I have an idea, I don't need to run and find a piece of cardboard and cut another little piece. I just like having a lot of different pieces around so that I can really quickly solve problems. The other thing that's really important to have are some little nails like this laying around, and lots of bamboo skewers, some tape, and then a nice box full of hot glue sticks ready to go, so you're not in the middle of something and then you have to go run around and find some hot glue sticks. So taking some time to set up your workspace really helps. But I want to talk a little bit about cardboard and cardboard quality. So I have 2 pieces of cardboard here. On camera, it may not even seem that they're that different. One is a little bit thinner. Now that's in and of itself is not a problem. But if you look really closely here, you can see that these corrugations here, these flutes, are not as evenly spaced. They're a little bit more rougher in there, whereas these here in this thicker piece are very uniform. That's because this piece of cardboard is from a recycled box, and there's nothing wrong with recycling or reusing, but this cardboard is made up of recycled fibers, which is great. This cardboard is most likely made of completely new fibers, and it is going to be the newer fiber cardboard is going to be a lot better for your prototyping, because you can see that this new cardboard is just not going to be as strong. The fibers are not as strong. They're shorter fibers. So this material crushes much easier. And also you can get a feel for this, but you can also like see how much easier, let's see, there. It's much easier to rip this material, much easier to crush it. And when you're cutting it, it is harder to get a good cut through it without crushing the corrugations here. So when you're prototyping machines, especially, I highly recommend taking a look at your cardboard. And you can get perfectly good cardboard recycled from boxes, but sometimes, particularly things that are low-cost things that are shipped, this recycled cardboard is really not your friend. Okay, so normally when I would start a project, I would go to my sketchbook and start drawing out the mechanism. What I'm doing today is I'm going to try to figure out to make a mechanism for the top of this robot that makes the ears twitch. So I'm thinking I'm going to put like a servo here in the middle of this and see if I can get both ears to move with one servo. Now, of course, I could just attach a couple of ears directly to a servo, but I want to see if I can get only one signal out to my servo and get two ears to move together. So when we're thinking about how to get our mechanism to work, I always start from the center point of my servo, and I might like draw the horn on here like that to represent that. And then I know over here somewhere I want a set of ears to move, so I'll draw my ear. I'll represent that. I'm going to have two ears here. Represent that just by I'm looking down on this robot head and the ears there. Okay, and the next thing I want to do is because I'm going to put the direction of my servo, and I know it's going to go in both directions, and I want to put the pivot points of my ears right in line with the center line of the servo. And this is really important if you want things to move in tandem like this. So now I'm going to represent maybe a little piece of cardboard that my ears sit on. And now I will connect this and this like that. So that means I'm going to try to follow the motion here. And the more you do this, the better you learn to visualize it. If I turn, I'm going to get rid of this so don't confuse myself. If this turns this direction, that means that this is going to turn over here, in that direction. And that means that this rod here is going to go that way. So that means if this is turning, then this is also going to turn this direction. And the same, because I've connected my rod on the other side of the center point here, this one will turn in this direction. Now wait a minute now. That means that this ear is going to go from here to here, right? And this ear is going to go from here to here. So the ears will move together, and that's not what I want. I want the ears to move in like that. Okay, so what can I do differently here? Well, what if instead of connecting here, I connect over here? So now when this goes in this direction, this rod will go in this direction, and that means that I'm going to turn the other way, because I'm on the other, this is on this side of the center point, and this is on this side of the center point of rotation here. So that means that will give me that rotation that I want, following this rotation. All right, so that's a good thing, but I think what that will mean is that I will need to move the center point of this closer, move it up closer here so that the center points of these are more uniform in reference to the center the center point. So you can see how quickly it gets a little difficult to describe this. So I think the next step for me to do is to just start prototyping this idea. So for my next phase of prototyping, I have 4 pieces of cardboard, which I've hot glued together, making the grain go in opposite directions, by the way, so that makes it a little bit more stable. And this is going to be kind of my pin board to test out those ideas we drew on the whiteboard. So first I'm going to represent my the horn of the servo with this little chunk of cardboard here. And so I want to put some pins through there like that. And I find it useful sometimes to have a little piece of foam here to provide some backing for when I create these initial holes, so I don't have to poke through my finger. And then I want this guy to go through here like that. Okay. And I'm just going to put this about here in my cardboard. Now I have this nice pivot. Look at that, a little bit more secure. So it keeps it flat. All right. Now I need to represent my ears in some way. So I think these would go here and here. Now I think what I want to do is actually take this back out, if possible, and take a moment to draw a few lines on here. It doesn't really matter if it's square to the outside of this, it just needs to be. I'll put that like that, and then I'm going to make some assumptions about where I want those pivot points to be. And let's for starters, try about, I don't know, 3/4 of an inch here and here. Of course, you could just start pinning things in, but I know that I want to. One of the keys to prototyping in this way is that you can be fast and loose, but you still want to try to be as accurate as possible. And then I'm going to attempt to just sort of estimate. Maybe I'll put this pivot point over here. Yeah. Oh, I should go ahead and add a rough center line here. Not quite parallel. Maybe these are here, 2 inches, and here. Okay. Now I need to also take my 2 pieces, my ear pieces, and they're cut uniformly. And I'm going to make an estimate about approximately where I want those holes to go. And then I'll just put these together. Okay, now I have 2 pieces here. Okay, that have similar points laid out on them. And if this hurts your finger to put these nails in just with your bare hands, you can always use the end of a pencil or something like that to push it through. And the more you put these in and out, the less secure they could become. But for something like this, you can always get another piece of cardboard if you need to, or just move the pin over a little bit. So now I'm going to stick this through here, put that through there. Oops, forgot I need my pin sticking up here. There. You see, that's already satisfying, even though I'm just moving it with my fingers. It's already, you can start to feel the life of what those ears might look like. Now I'll take my representation of my servo horn here, push it down in there. Okay. Now, for just doing really quick prototyping like this, I like to have a few strips of chipboard. This is actually from my Cheerios box. And that's what I'm going to use to connect these points here. So I might bring this over here, make a mark like that. Let's see, this chipboard's a little bit more dense. I'm not sure if I'll be able to push this through with my bare hands. Nope, not too bad. Guess I don't need all of that. I'll leave a little extra in case I change my mind. Okay. Now I can see my horn is moving. Okay, that looks good. Put these ears kind of where I want them so that they're parallel when my horn is 90 degrees. Looks like I've got a little bit of a cant there, that's fine. And do the same thing again. Okay. So now these ears are turning in the same direction. Is that what I wanted? Not really, no. Oh, I remember what I did wrong. Now what happens? Aha! Much better. Looks like they're not quite working in parallel there, but that's why we are working in cardboard. We can fix that. Better. Still not quite right, but we can see that we could get there. So now we have two mechanisms in one. We have a twitchy ear thing, or we have maybe tracking eyeballs. Same mechanism. Now we can move these pivot points all around, but you can see how much travel I get. I'm not going to use near the full amount of the servo rotation to get the movement I want here. Okay, so now the next phase will be to translate this mechanism into something that's driven by a servo. All right, so I guess the first thing I'll have to do is take apart my mechanism. Of course, you could also just leave this and use it as a guide to make the rest of your project, but I think we'll just take it apart because we have the confidence that we can put it together again. I'm going to leave these ears here for now, and then use this same center point to place my servo. So there's the center of the horn. I guess I decide which way I want my wires to go out. I think I'll do it this way. Now, one of the things I see challenging people when they're making things in this way is getting this servo secured. Because if this servo is not absolutely secured to your base or some other material, then when it moves and is pushing other materials, you're going to lose a lot of energy here if you're also moving your servo. So I like to make sure I find a way to get that really secure. And so in this situation, I'm just going to trace around it like that. Fill that in. And then I'm just going to see if I can create a hole. Now you might be thinking, that seems like a really brutish way to make a hole. Why didn't he just use a nice snap blade like this or some other thing? And I just find it's a little bit faster to go about it this way and get that little bit of extra fluff in there. It gives me a little bit more friction to hold this in place. So now my only problem is I don't have quite enough space for this wire here. Let's see what happens when we push it through. I don't want to squish that wire too much in there because it might want to short out. Oh, that's not too bad, actually. Okay, now that's nice and secure. I didn't use any hardware. I didn't, it's not hot glued in there permanently, but it's going to be just secure enough to continue my prototyping process. Now, this is something I'll need to be thinking about when I'm building my final one. I'll probably need to manufacture some kind of plate here to hold this in place. But for what I'm doing right now, this is going to work just fine. So now my next problem is I need to connect my servo to my ears. And the first problem I have to solve is the fact that my servo is up here and my the plane of the mechanism is down here, right? So whenever we're making mechanisms like this, we want to try to keep everything in the same plane as this horn. Now, there's different ways to solve that. One, we could just elevate all of this up. We could put some posts down here that maybe don't interfere here. Or, we could try to just connect directly here. But the further you get away from this plane, the more energy is going up and or down and away from your mechanism. And you just get, your results will not be as good because you're going to be transferring energy away from the plane of rotation here. So I think my solution will be to I'm just going to take these things, build a little base underneath there and elevate them. So. Okay, now I have my two pieces of cardboard which will elevate my ears up. And I think the first thing I want to do actually is give myself a little center line here, just in case I need to transfer any measurements. I can do so, and it will just help keep things uniform. So what's important about this method of work is knowing where you can be sloppy and fast, and knowing where it's worth taking some time to lay things out with a little bit more precision and care. All right. Now, I could have, of course, just hot glued these in place, but when I can, I like to keep my options open so that if I need to move these bases or if I want to reuse this for something else, I can do that. And this, for what we're doing right now, is plenty secure, especially since I haven't taken these out again and opened up those holes. This is going to hold just fine. So the next thing I need to do is place my ears back where they were, and I took note of that. So now that I'm looking at it, I feel like I'd really rather have this point a little bit closer to the center point of my servo. So I'm just going to make a quick iteration on the fly here. And that's why we do it this way. So now the next thing I need to do is connect my servo to my ears here. And I realized that I have grabbed the horn with the longer, that's longer on one side than the other. So I'm going to go ahead and switch that horn out to the one that is more uniform so that I can put holes that are equally spaced. And now is probably a good time to make sure that my servo is centered up where I expect it to be. That's pretty close, but I think I'm going to see if I can get it centered up a little bit better. So now we need to connect this here, and this here. And I like to use this think this is 1/32 rod. I'm just going to see if this fits in here nicely. Yeah, that works all right. So we shouldn't have to drill those out, but we'll see. So I'm going to take a length of this, just so it's a little easier to work with. Okay. Now the first thing I think I'll do is add a little eye to the end here, and hopefully you can see this. I'm going to use these round nose pliers. Grab the end here and just spin this around like so. I'd like that to be a little bit tighter, so I'll see if I can squish it here. There. Now it's a little bit out of plane, so I'll take my other flatter pliers and squish that down. And now I have a nice eye here. And I'm not losing a lot of energy here, because that's a nice fit. It's not too tight, not too loose. All right, so I'll position this where I want it. And now I need to make a connection down to here. So what I'm going to do is I'm going to put this where I think I want it. I'm just going to grab it right in that hole where I want to put it. I'm going to make a sharp 90-degree bend down. And this is where it's handy to have two sets of pliers. I'll just use my round ones here. Grab this here, bring it up like that. Let's see how this works. I'm going to chop my excess off here. Now I should be able to just drop this down here like that. And that's not going to go anywhere. Put that on there like that. And then I'll make one for the other side. Okay, so that looks like it's going to work okay. This is kind of springing up here, so that tells me that maybe I need to get this a little closer to 90. And this brass wire works really nicely, really easily formable. Now you could also, in a pinch, you could probably use a paper clip. Better. All right, let's test this out. So it's not quite even, but it looks really cool. So I can look and see what is different about these. I mean, is it just the placement? But it's still a nice effect, and I think it'll look great. And you can see I am losing a little bit of my movement here in that the servo itself is moving. And that's generally something I like to chase down. I know now this thing flipped up here, so what? I still have a few things I could improve here, so let's see what I can do about that. To keep these on here, sometimes I like to use just some scraps of EVA foam. And These can act like little nuts, I guess, on the end of your nail. Like so. And the other thing you can do to sometimes change you can bend these and take a little bit out or add some in. So if I bend this, now they're a little bit more uniform. The servo's still moving a little bit there. I don't love that. Let's see what we can do with this. Got a little bit better. As you can see, we're well on our way to having a working effect here. My next project would be to experiment with how I can hide this inside a head so that you don't see the servo sticking out there. And so maybe these mechanisms would live underneath another surface with the top of the head. But there's all kinds of fun that we have to have yet with this. But you know, it works pretty well. I'm pleased with it. Last thing I guess we should really do is give it a little bit more life here, so we can see those ears that I want to see on there. Oh, yeah. That's going to be great.